On this page of notes, we have an example for you to look at for the most part. I'll guide you through it somewhat, but to get practice doing the Kirchhoff voltage loop analysis and current junction analysis to solve for the current in every part of the circuit. Now, in this circuit, I've chosen current directions for us so we can compare our solutions and our analysis and talk about how to get the answers. So I took I1 coming out of the battery here. So I1 combines with I2 coming down and makes I3 coming out of junction A going into junction B. I3 will combine with I2 coming up and I4 then going to the right. Junction C, I4 comes in from the left, I2 goes up, I6 going down. I6 comes through here. It's our final junction down here, so that would be junction D if I labeled it. So 6 breaks into 5 and 1, so I am consistent. So we have 4 junctions, A, B, C, and D. So we have 4 junctions, so we are going to need n-1 or 3 equations. I chose junctions A, B, and C for my junction equations. My loops I have shown here, right? My loop 1 is a clockwise interior loop. My loop 2 is the interior clockwise loop up here. My loop 3 is the bottom. And as I said previously, you can choose other loops, but to just compare our equations and talk about any questions in your analysis, choose these as your loops for your equations. So what you should do now is pause the video, set up 3 junction equations using A, B, and C, do your 3 loop equations, and see if you get 3 equations and 3 unknowns that we're going to have in our result. Try it on a piece of scrap paper if you're unsure to want to just put it into your notes at this point. And when you unpause, we can take a look at the further analysis. So pause here. Okay, hopefully we are back and in business. Let's see how we made out. So here I have my junction equations that at junction A, we have I1, right, coming up. It combines with I2, as we said, and we make I3. So there's one equation. At junction B, I have I3 combining with I5, making I4. So that's consistent. And I have I4 breaking into I6 and I2. So there we go. So we have our 3 equations. And when we do our matrix, we'll put our coefficients of 1 in front of them and rearrange them to match them up like we did before. We'll see that in a moment. But first we have our loop equations. So here we have the loop coming out of the positive of the 4-volt battery, so that's why that's a positive 4. I have the loop would be passing in to the positive, so that's why it's negative, so that's the 4 minus 2. There are no internal resistances in this problem, so we don't have to worry about the internal resistance for this problem. We have the loop and the current going in the same direction through the 20 ohms. That's why we have the positive. We have the loop and the current going in the same direction through the 10. So that's why that is positive. And then we should have, yes, we do, the loop going down and the current going up opposite direction. So that's why we have the negative on the 10. And again, pause the video here and make sure that you understand the purple loop and the blue loop equations. So pause it here and make sure you understand those equations. Okay, hopefully those equations make sense and we can take a look at our matrix. So when we have our matrix, I took equation 1, so this is equation 1, and we have 1I1 plus 1I2. Notice I3 is brought on the other side, so that's why it's negative I3, and then we have to plug in zeros, right? 0 for I4, 0 for I5, 0 for I6, and then 0 left on the right-hand side of the equality. So this would be our, put them there as our equals, but that really would be our equal sign. And we have then our other equations. This row is equation 2, equation 3. Let's take a look at equation 4. Here we have I1 is the 20, so that's where the 20 comes from. We have no I2, so we have a 0. We have 10 for I3. We have no I4, so that's 0. We have negative 10 for I5 to negative 10, no I6. And then 4 minus 2 is 2 for 4. So please check that equation 5 and equation 6 work out as well. When you do that, make sure you can plug in your 6 by 7 matrix into your row-reduced echelon form, and then check your answers. And keep in mind that all of the negatives here mean that we just chose the wrong directions. So unless you're told to go back and show the correct directions, that's fine. As I said, most of the problems ask you to solve for the magnitude of the current, but certainly if we were going to carry the analysis further, we would want to change those directions to make sure we understood the proper direction. So I'm going to zoom back out here for a moment, pause it, let you take a look at it. We'll also discuss this in class. And of course, please ask questions. This type of analysis is really important for us to go forward in this chapter.